there's a point in time with some of this sometimes where we have to just call it. Like you've tried and tried and tried, and you might just want to, let's actually see what these answers were supposed to be. All right. For the first 4 problems, I did way too much work on way too little of a space. But you don't judge me. Yep. I heard that. But your answers going through them, number 1 was -2 minus root 3. 2 was... 2 is root 6 minus root 2 all over 4. 3 is... I'm just loving the sounds you guys are making right now. 3 is root 2 plus root 6 all over 4. And 4 was root 6 minus root 2. This is you know what? I'm glad we are awake and we're having reactions, even though they're not necessarily the reactions I wish they were. That's okay. Oh dear Lord. You can do that, definitely. But the point I wanted you all to see, ladies and gentlemen, please. The point I wanted you to see with number 2 and even number 3 is if you don't like that angle because it's not within your unit circle, you are always welcome to find a coterminal angle. Okay? So there's no way in heck I personally would ever want to do the sine of 735. So I kept subtracting 360 until I had an angle within my unit circle, which made it, at least for me, significantly easier. And then it's a matter of, oh dear Lord, can I get through the whole thing without making an arithmetic mistake? No? Is that what your answer was? Hey, we're honest. It's okay. I messed that up a lot also, but this is why it's very important you guys show your work with this, because I am fully aware that there are a ton of tiny little things going on here, and one little mistake will make the final answer wrong. So if I can go through your work and pick out where your mistake was, I can give you credit for the stuff that you did get right. Okay? So make sure, I did grade, I don't know if it was this class or not, but I did grade some quizzes where I literally had no idea what it said. I could not read the handwriting. I could not read. Okay? So please make sure that I can find what you're thinking about, that you're showing for each step, everything. That way I can give you as many points as possible. Questions on 1 through 4? Yes, ma'am. I can zoom in. I don't know what you're on. Okay. I just really had no idea what question you were looking at. Extreme close-up. The big thing with number 4, you may not do a reciprocal until you have divided by 1 full term fraction. Okay, so you can't do reciprocals here. I can't just say, oh, it's going to be 2 over root 2 times 2 over root 3 plus 2 over root 2 times 2 over 1. You cannot do that. Yes, sir. Root 2 minus root 6 is not correct because it's the root 2 that has to be negative and the root 6 that has to be positive. So if you had done negative root 2 plus root 6, that would have been okay. So my assumptions, where would you have made that mistake? I'm not quite sure where that extra negative would have come from. What angles did you use? 9 pi over 12, which is 3 pi over 4, and pi over 3. So my assumption would be that when you were going through for your 9 pi over 12, you probably had signs wrong someplace with that. So 9 pi over 12 or 3 pi over 4 would have had a negative cosine and a positive sign. because that's in the second quadrant. Sophia. Nope, don't like you, not going to do it. Boop, just kidding. And I looked at negative pi over 12 as 4 pi over 12 minus 5 pi. No, I didn't. I did, what was that? 3 pi over 12 minus 2 pi. No, I didn't. 3 pi minus 4 pi. Sorry. Yes, thank you. Thank you. Yay, numbers. Woo. See, 2 plus 3 equals 6. No, it doesn't. It's 4. 5. I'm going to get there eventually. I'm doing it on purpose. Please. Okay. Okay, so I had it pointed out to me, thanks, Theo, that I could have done 5 a lot easier. But I didn't see it, so I turned everything into sines and cosines and worked my way through with that. What would have been easier, what is cotangent squared in terms of Pythagorean identities? Cosecant squared minus 1. And so if I did that and then I multiplied top and bottom here by cosecant plus 1, it actually would have kind of gone a heck of a lot faster. Do you want me to do that? It was like, ooh, let me see. Easier? Yes. Okay, so here we go. It starts off with cosecant theta over cosecant theta minus 1. I'm going to go ahead and I'm going to change this into cosecant squared. Whoops, need a c, need a theta. Minus 1. Okay, just to make my life a little easier. So I've made that one change to start off with. And because I know I'm going to leave it in the form that it's in, but I happen to know this is cosecant theta minus 1 times cosecant theta plus 1. I happen to know that's how it factors out. X squared minus 1 is x plus 1, x minus 1. That helps me figure out in order to have a common denominator, I need to multiply this guy, cosecant theta. Times both the top and the bottom. Why do I keep writing cosine? That would leave me with, I would have cosecant squared theta plus cosecant theta all over cosecant squared theta minus 1. And I'm going to take that negative and I'm going to distribute that up on top here. So that would be minus write anything. Gosh. Cosecant theta minus 1 over cosecant squared theta minus 1. So, no, it's minus 1. Okay. And then when I combine those all together, I will have cosecant squared theta plus minus, cancel each other out, minus 1 over cosecant squared theta minus 1 equals 1. That would have been a lot easier than the torture and torment that I chose to do for that problem. It's okay. All right. That's okay. If you like this one better, that's perfectly fine. It's just to show you that there are multiple ways to do each problem. Yes, sir. Yeah, you could. Theo, turn around. Okay. Yes. Well, I hadn't even really showed 6 yet. What I did for 6 is basically started with the idea of a common denominator. I have 2 fractions. I want 1 term. So the common denominator would have been 1 plus sine theta times 1 minus sine theta. Just be super careful with that negative sign. And I oftentimes will write it like this just to make sure I don't make that little mistake. My biggest mistakes tend to be with little things, copying things down wrong, missing negatives. So I know I've got to be super careful and take whatever steps I need to get that done. Okay? When I FOIL this all out or distribute it, I have sine plus sine squared minus sine plus sine squared. So the minus sine plus sine cancel out. That's 2 sine squared. Multiply all the bottom out, gives me 1 minus sine squared, which is cosine squared. And right here, I see the tangent that I wanted, the tangent squared. Okay? Now today is mostly going to be about practice. I'm going to answer some, not all of them, I'm going to answer some homework questions. And then we're just going to do classwork. The end of class, we'll get some notes to start working on the next piece. Okay? If you'll notice, I did not check homework today. I am going to be checking this homework next class. Okay, I'm giving you a little bit more time to kind of polish it up a bit. All right, so I'm hoping that today's practice helps that. And I hope doing the homework helps today's practice. The one that's due today, I'm going to be checking next class. You're not getting any additional homework today. Okay? All right. So let's see here. Your homework was on page 481, I believe. Okay, Sophia had her hand up first. Sophia had her hand up first. Yes. Number 20. Okay, 20. And I'm not going to do all of these because, again, I'm giving you guys time to finish this. I'll do a couple of them. 20 gives me the cotangent of negative 5 pi over 12. I have a couple of issues with this problem. The first one is that that's not in my unit circle. So if you want to stick with this and leave it like that, you can. I prefer to find a coterminal angle first. So a full circle is what? 2 pi, right? And if I wanted that in terms of 12, 24 pi. So I'm going to add 24 pi over 12 to this just to get a coterminal angle. And I will have, what is negative 5 plus 24? 19. The other thing that bothers me about this is the fact that that's cotangent, and we didn't have a direct formula for cotangent. We had tangent. So cotangent in terms of tangent, what is cotangent? 1 over the tangent. Cotangent is 1 over the tangent. So I'm going to do 1 over the tangent. And how can I get 19? How can I make 19? If I'm thinking about over 12s, 19 is an odd number, right? So one of my numbers is going to have to be odd. There's only one number I can put over 12 to simplify to a unit circle. Oh, I'm sorry, there's a couple units. 15? We'll do 15. 15 and what? 4. And that's going to be an addition problem. Because 15 over 12 is what? 5 pi over 4 and pi over 3. You really have a choice with tangent because I know I'm going to be doing reciprocals. and this whole thing is a fraction, 1 over this whole thing is just going to be the reciprocal of this. Do you understand what I'm talking about there? So I'm going to turn this tangent with addition into this, but I'm doing the reciprocal because it was 1 over. All right? That means I now have the top becomes the bottom becomes the top. That gives me the tangent of 5 pi over 4 plus the tangent of pi over 3. And then 1 minus their product. Oops. Tangent of pi over 3. Now we get to the nitty-gritty of this. I personally think that's the easy part because I haven't had to do any numbers or unit circle. It's just, hey, I have a formula. Let's use said formula. All right. Pi over 4s have nice tangents. What is the tangent of any of my pi over 4s? 1. I need to think about the quadrant that it's in. 5 pi over 4 is in what quadrant? Quadrant 3. Okay? In quadrant 3, tangents are positive. So that's a 1. That's a 1. What is the tangent of pi over 3? Root 3. Leaving me with 1 minus root 3 over 1 plus root 3. In order to rationalize this, you all have to understand that it is the denominator that we look at, because it's the denominator that I have problems with. I want to make that square root in the denominator go away, and the reason why we multiply by the conjugate is because that makes a difference of squares here. That means, and ladies and gentlemen, please always put your parentheses in there. That's very important. What is the conjugate of this? 1 minus root 3. And I do both numerator and denominator times that. And the joy of FOIL. First, outer, inner, last, over first, outer, inner, last. That gives me 1 plus 3 is 4 minus root 3 minus root 3. These two cancel out, 1 minus 3. And then simplifying gives me negative 2 plus the square root of 3. Craig. I love these. Y'all hate them. I love them. Okay, 58 we said? 58 gives me the cotangent of alpha minus beta is equal to the cotangent alpha, cotangent beta, plus 1, all over cotangent alpha. Where did it go? Minus cotangent beta minus cotangent alpha. And I left off the 1. Okay, here we go. I don't have any trig identities for cotangents, do I? But cotangent is 1 over the tangent. So far, so good? And that means I can take my tangent formula and that's tangent with minus. It's this guy right here. And do the reciprocal of it. That means it will be this over that. I have now, pen that's coming undone. I will have minus, that's 1 plus tangent alpha, tangent beta, over tangent alpha minus tangent beta. You have a couple of choices at this point. Do you want to go sine and cosine? Or do you want to put cotangent and tangent into either all tangent or all cotangent? Doesn't really matter. Sine, cosine. So if I do sine, cosine, I'm going to go ahead and start with this side. That's going to be, cotangent is cosine over sine, cosine over sine, cosine over sine, cosine over sine. And I'm going to do the same thing over here. So tangent is sine over cosine, sine over cosine. I feel like I'm saying the same thing over and over again. Am I saying the same thing over and over again? Ah! See, I stopped saying the same thing and I messed it up. Sine over cosine and sine over cosine. How can I make those fractions go away? Multiplied by the denominator, what the common denominator would be. So for this left-hand side, what would the common denominator be? Cosine alpha, cosine beta. And if I'm looking at the right-hand side, what would the common denominator be? Sine alpha, sine beta. Hopefully this will all go away and make me happy. When I distribute here, I will have cosine alpha, cosine beta, plus, when I distribute over here, cosine alpha, cosine beta, those simplify away, leaving me with sine alpha, sine beta. When I multiply here, my alphas cancel out, leaving me with sine alpha, cosine beta, minus, when I multiply over here, my cosine betas cancel out, sine beta, cosine alpha. And I really hope, and I do have in myself here, that this is going to work out nicely. So when I distribute coming back this way, I have cosine alpha, cosine beta, plus sine alpha, sine beta, all over. When I distribute here, my sine betas will cancel out. So it's going to be sine alpha, cosine beta. When I distribute here, my sine alphas cancel out. Minus sine alpha, cosine, I'm sorry, my sine betas cancel. My sine alphas cancel out. Sine beta, cosine alpha. Left equals right. It's a booger. There's a lot going on there. My brain hurts too. I don't know which part you're looking at. Are you looking at left or right? So you're okay with the one part. Are you okay with this part? Because those guys go away. When I look here, times distribute it here, cosine alpha over cosine alpha cancels out. And when I distribute over here, cosine beta cancel out. Okay? All right, I know there's still some more questions, but we are just going to be practicing today, and I'm giving you a little bit more time to work on some of these problems. All right? What I have for you today if I can figure out where I put it, there it is. You have a little worksheet with 10 problems. 10 problems. Please listen up. Do not do your work on this page. Put your answers on this page. Only put your answers on this page. You have 6 of the standard sum and difference. 2 of those slightly different ones, which actually I think are easier, wink, wink, nudge, nudge. And then you have 2 verify. Now on number 10, there's a very, very big hint. It says tangent is sine over cosine. That's very important because what is the tangent of pi over 2? Tangent of pi over 2? Undefined. That's why we cannot use the tangent here. So my hint to you is this. You guys listening? Do not do anything with the tangent. Do not think of that as the tangent formula. Don't do anything with tangent. Change it immediately before you go any further to sine and cosine. Okay? That is my big old hint to you. I'm going to give you 30 minutes, 10 problems.